The short talk I'm going to give is about one of our recent DSM2 modeling practice. It's on evaluation of the summer operation of Suisun Marsh salinity control gate, about its effect on the delta-wide water quality. This is a in-progress project we started early this year. So what I'm going to show is some preliminary results and to share with you how we use this model. As you can see, this is teamwork from our modeling section with Kevin, Eli, Nikki, and at the same time we collaborate with other divisions like operation maintenance. Notice Suisun is here, and also from the DES. Sorry, putting wrong there. The environmental service from Michael. He's a project leader, and also Ted Sommer. At the same time, Anchor QA, the consulting, they did the on-stream modeling for Suisun Marsh last year. So we are kind of the subsequent modeling effort after them to looking at the delta as a system model, and then also for the long term. So first, about some background introduction. As you know, Suisun Marsh, that's essential habitat for delta smelt. It's critical for their feeding, for their growth, for their survival. At the same time, this is also a very complex habitat because it's highly influenced by the tidal from the bay. The plot here is I borrowed from Chris Unright's presentation about the Suisun Marsh. The salinity gradient shown here, you can see from the flood tide and ebb tide, the salinity gradient change a lot, which as you know, the delta smelt, they prefer low salinity. So in that sense, how to control this marsh in low salinity zone, that's critical part. And the control gate is located here on the Montezuma Slough, close to the Roaring River. And what I pick here is the ebb tide and the flood tide along the Montezuma Slough. So take a look at the gate. It's like a three-part here. Here is the flashboard and the radio gate, and also the bolt lock. So the typical operation for this gate is happening October to May, and basically we just open the gate in ebb tide to let the fresh water into the marsh, and it's about 2,000 to 3,000 CFS, and close the gate. Close the gate on flood tide, then the fresh water cannot get out. The logic behind this is, the Suisun Marsh, the Montezuma Slough is a kind of a narrow slough compared to what we have here for the confluence. So the same amount of fresh water can really push into this marsh. Also, this marsh is like it's a shallow, so same amount of fresh water can benefit a large area. And attach a flow plot here, and with 15 minutes as a tidal, you can see, and also the red line is for the kind of daily average. You can see this is just capture the time when this gate operation happens. So you can see the freshwater net flow downstream. It's like has been elevated. So this project, the reoperation project, is included in the delta smelt resilience strategy, and it's proposed as action 4. And like you remember from the last slide, usually it happens in the winter for the operation. So right now we think if it's doing this good, why don't we move it to summer to see how it goes? So this this year in summer, August, DES, the Environment Service, is going to do a pilot study. So, and we were asked to do a modeling before this to see what the model shows, what will happen in this summer. And so the objective and scope of this, our modeling study, is just to, we are going to first take a look at what happened in history to see what the pattern is like, and also we are going to, the major focus is to make a forecast modeling to see what happened for this summer. And as I put up down there, we have a water cost optimization analysis which can strengthen our forecasting. I will show you later. So this slide gives a brief about a scenario we're going to run, like for historical and for forecast. The base definitely is the normal operation, which means no operation, and the real operation is we're going to apply the same typical operation in winter to summer, and from DS request we're also going to run some additional few scenarios, like to only operating the gate for only half time, and from their plan, actually, like there are 3 radio gates. From their plan this summer, they have 1 gate for under refurbishment maintenance. So we also show a little bit about how this will influence the whole project. So what's our concern about this study? Like I said, we have 2,000 CFS into that multimodal slough. So that benefit that habitat, the marsh. So the intuitive thinking is like, okay, you have that 2,000 to 3,000 CFS there. So are they going to negatively impact other places, like especially from the South Delta? So the concern is about water standard in the Delta area, and we investigating, like as you know, there are many flow water quality standards across Delta, especially at the confluence area. But after the inspection, we found actually the Jersey point. That's a dominating standard we should be concerned about. One is, like you all familiar with, is D1641, and especially for this year is below normal water year, so it's like it's this standard we're going to apply. So it's like from April to June 20th, we have like a 0.45 EC. We need to stay low, and another one is from June 20 to August 15. That's like 0.74. We need to beware. And at the same time, for Jersey, for you, if you're not known, there is also actually the guidance standard, which is designed for the Contra Costa that diversion. It's like, actually this one is all year round. It's like a 1.64 minimals, like all year round. And I'll show you later. This one will kick in September. And I'd like to point out here for Collinsville, actually this one is included in the bio-opinion after 2009. It's called the 4x2 standard. It is not active for this year, but it's going to be active for above normal year and wet normal year. And as the project proposal, this reoperation for the gate will only happen in below normal year and above normal year. So we're not going to worry about the Collinsville this year, but later on we are going to worry about that, because this one actually it's even stringent constraint for the flow. So I'm not going to give you a comprehensive validation about our model. You guys saw that in our previous session and in previous years when we released 8.12, and so here just some quick snap about how our model performed. in our concern period. So we pick like 2 representative years, 2005 and 2012, because this is the above normal year and 2012 is the below normal year, and we check the period, which is summertime, to see how our model match the field data. And as you can see, like 0.8, that's the number showed here is correlation R square with the daily average of our model result and also the field data. It's good. It's not like perfect, but it's good. And at the same time, this one, national still, that's a location behind the control gate. So this is also the area we concern. We don't have data until 2008, so we only have like one comparison here for for the 2012 for the summertime. This is all the EC comparison, and since this is a area we concern, I attached 2 other number here. This is this is the whole period starting 2008, since when after it got data, into 2006. So the red one is about when the gate is operating, and the yellow one is like when the gate is not operating. So take a quick look at the time series. I know number could be good, but let's see what the real time series is like. Here is showing the national still. Upper one is flow, and below one is EC. I don't know if you can see clearly about the gray area. That's gate operating time, and the blue one is field data, and we have DSM2 with the orange one. And you can see we got pretty consistent with both. We have in the range, and also we catch the up down very well. And the concern is like when the gate operated, that's like, and you can see we captured the water flow elevated, and at the same time you can see when it's operated, the flow, the EC drops. So discrepancy, and you can also see here, we have kind of underestimate our net flow about like sometimes 500, sometimes even bigger. Although sometimes like this, we're not sure if it's like the sensor problem. So after this, take a quick look at also the station we concern. First of all, Edmonton. This is field data is also picked in the blue, and we have our DSM2 modeling result as black. You can see it's also in the same range, similar pattern, but we are overestimate like somewhat, and the dashed line is we apply the reoperation first in the historical time. So you can see the reoperation really elevated the EC about like less than 10%. But for Edmonton, that's why I mentioned earlier in the slides here, Jersey Point is our concern location. Edmonton, you can see the standard, the relevant standard actually is it stop at like August 15. So this elevation actually didn't bother us too much. So when it comes to Jersey, this is what going to happen. So first of all, you see it's tightly touching Jersey, like what happens here, and and another thing is what I mentioned about the guidance standard. For the Contra Costa, that one, this is the dash red line. For the historical, definitely you can see in real operation, operator did a very good job. They didn't break it, and they kind of just touch it. And but we have introduced the real operation from the dash line here. You can see it will be increased EC peak about like 14%. We admit, as you can see, we overestimate Jersey point EC. You see here and here, but even accounting for that, the real operation is still going to break this. For the starting period, like D1641, the regulation, it's okay because the EC rising, it's like from the later August. So bear in mind, and that's what's going to affect our forecasting modeling. So for our forecasting, that's our concern of focus of our study. So basically, we're using our current grid and parameter, but we request the OM like hydrology, forecasting for hydrology for the whole year, and also from our previous boundary, we're using the astronomical. I'm not going to go detailed in there, and you saw a little bit in Inez's presentation. For the data structure, we got from the related agency who control these structures, and from EC boundary, we get it like we generate like more from our in-house planning scripts. So with this input, what we're going to happen is like this. So as you can see, our first without also the reoperation, what will happen is like you can see we violate the standard. Like here, that's the D6441, and also here for the guidance. The reoperation for the concern of this project, the control gate reoperation actually won't increase too much. Like you see from the reoperation, that's a dash line here, that's the one, and the two scenario in between, that's like kind of half operating period. Yeah, so I think right now people's concern is like how are we going to violate, how well we're going to do if we violate this. So this will not happen because this is now the near-term forecast is a long-term forecast. It's called seasonal forecast. In the real time, operating and maintenance OM, they are when they come to near term, they have done very good job, as I show here. For in history, in real life, they will only touch this. So why we happen in the forecast? That's because we're using like a low resolution hydrology, like that's monthly, and also because it's like it's a long-term forecast. It's like right now it's like 5-6 months from now. It's not like what we usually do for near term. So operator can have the capability to adjust the flow to meet the standard. So this is only the phase one of our forecast. So what we are going to do? So for modeling, we need to introduce this water cost analysis. So basically, this is a kind of a constraint optimization, which can minimize the flow, which can meet the quality and the flow standard. What happened, like in here, it's just like kind of like we just throw a dot there because that's based on our empirical or our previous experience. So with this tool from the some more introduction. It's one more. We're using a library called Compiler. It's about the linear approximation, and we also apply some mild regularization to keep a solution in the calibration zone, which can prevent the wacky results and some unreasonable or crazy proposal. But the thing about this tool is like we can find the efficient frontier which can meet the standard. At the same time, we won't waste the flow. That's the reason why we're using this tool, because in real time, this is what will happen. The operator will operate the flow to meet this standard, but they also won't have like release too much water to fall too much behind the EC flow. So this is the reason why we use this is because this is a well-defined problem. We want to achieve this standard, but not fall too much, and we are not over this. And from the result given before, we can see this tool can give us a result very close to the realistic operation pattern. Here is a plot. I'm going to show you. It's like you can see there's two curve lines from efficient frontier. You can regard them as like two operation scenario, because in the end, all the scenario in the real life, we're going to meet the salinity standard. So the real comparison happens is between the water cost, because at the end, for jersey point, you will see all the EC will going to touch that standard, but not fall behind. But they're all similar. So the comparison actually is between like how much water between these two scenarios. If we don't have this tool for the like forward modeling, it's like what we showed before. We are going to release maybe operate using the same hydrology, but we apply different operations. So that would be more like a comparison between like this, like a vertical line. Okay, kind of short. So I'm just going to show quickly about the results. So this is after this optimization analysis, what will happen. So this is the real forecasting, and the two curve line here. One is the 14-day running average, which is the green orange. You see it touched the D641 standard but not break it. And for this blue one, that's the filter EC, which use as the surrogate for the daily average, which is the guidance standard requirement for the Contra Costa. So it's also, you see it touched the standard but not too much behind. So we apply the same method to all the scenarios. So what you see here is like all the scenario here we achieve the same goal. We won't violate the standard. And here I didn't show the the daily one, but it will be similar like this one. So they all achieve the same one. So this is the real forecast looks like. And to how to compare all the scenario, that's what I show for this one. So we compare the water cost. So for here, it's like, okay, so what's the water cost? So attached here is net data flow. That's a summary flow for the entire system. So this is all the comparison between the scenarios. So and since it's too crowded, I'll just give you a table to see what the result looks like. So for average flow, our reoperation will introduce like 128 CFS average for that's per and for if we apply if we convert it to TAF for the whole period, which is like from July to October, 105 days, it's about like 27 TAF. If we apply for the two other scenarios, only half all operation times, that's also nearly like half the water cost it is. So I'm going this is very brief about the gate. So because this summer they are going to have one gate under maintenance, but at the same time this reoperation proposal is going to happen. It is going to propose for 3 gates all operating. So we do like two things altogether. But as you see, actually 2 gates open. Actually, the flow efficiency is pretty much like over 90%. And we repeat the same water cost analysis for the forecasting. It's also very minor differences. So some wrap up for this preliminary result of our subject. The reoperation didn't introduce water quality in the delta very much, not as our first intuition like, and as we quantify the impact, the water cost it's also it's small. It's like only about like 10 to 25 TAF, and also for the half operation, it's also only like half what it costs. As I said, this is ongoing progress, and the current hydrology we're using is February. From this February, from the OEM. So every month they're going to have a new update hydrology. So we will follow up to update our modeling. And at the same time, most important, they are going to have a pilot study for this summer. So on the feedback, we can refine our model. You see the multi-zoomer slew, the salinity discrepancy there. We are thinking about like bathymetry and other data that could be the reason why it happened there, because you have like a 500 CFS difference like that could also kind of over our EC at Jersey, like south other places. And at the same time, as I mentioned, this proposed action is going to happen in both below normal year and above normal year. So we did the below normal year because this year is below normal year. But for above normal year, actually that's more, even more critical, because it's going to have a 4x2, even more stringent standard. We don't have above normal year for the recent 10 years. So the only representative year above normal year we found is 2005, and that's like before the 4x2 4x2 standard there. And if that's going to happen, we could expect maybe more water cost. And if there will be more water cost, like even much bigger, there will be potential. We're going to incorporate the calcium to do a system-wide study and to incorporate like a long-term, very like hydrology, plan. That's wrap up my presentation.